Now we are looking at quadratic equations. We will start with the standard form of a quadratic equation. The standard form is that of ax squared plus bx plus c is equals to 0. We know this thing. Now the reason why we are looking at the standard form is to predict the shape of the quadratic equation ka graph. Now for a being positive or negative are the only two cases that is possible, because a is a coefficient, it's a constant term that is multiplied to the x squared variable. If a is positive, we typically get a curve like this, an upward U, and if a is negative, we get a curve like this, a downward U. You can call them parabolas as well. They are parabola in fact. So an upward parabola when a is positive and a downward parabola when a is negative. So this is the shape of the graph of a quadratic equation. If you consider this to be a function f of x, then this is a quadratic function, and a quadratic function will have roots. Okay, now let us try and understand what a root is. So roots, we all know alpha, beta are the two roots for a quadratic expression. Any equation, beta quadratic, let's say even for cubic, bicubic, biquadratic and all. So the degree, the highest order of a expression or a equation is a degree, and whatever is the degree, so in this equation the degree is that of 2, will predict the number of roots. So number of roots for a quadratic equation will be 2. So we are representing them as alpha and beta. Roots are typically also called as the zeros. When you substitute the value of the roots into the expression will become 0. That is the meaning of a root. Okay. Now let us try and understand how we can calculate roots. Okay. So the very first method is the one that we have been familiarizing ourselves from the school days, which is that of a factorization. This is also, I like to call it the mid split, the middle term splitting. So I'll take an example. So say x square plus 15x plus 56. So the middle term splits work in such a way that you have to give me two numbers, the product of which will be 56 and the sum of which will be 15x. Either if you are a little bit, good with maths, you know the numbers are 7x and 8x, in which case you can directly write the roots as x plus 7 and x plus 8. This is the factorized form of this expression, x square plus 15x plus 56. Or if you're a little slow, you can start off by the prime factorization of 56. So maybe 2 28s are, 2 14s are, 2 7s are, and because 7 is a prime, we'll stop at that. Club these 2 into 2 into 2, that is 8 into 7, 8 7s are 56, and you have the value. So when this method does not work, and I'll tell you, there will be certain quadratic equations in which the mid split will not work. In that we will have to use the quadratic formula. Okay, and the quadratic formula, I think everybody knows it. I don't really need to emphasize. It is x will be minus b plus or minus b square minus 4ac upon 2a for the expression ax squared plus bx plus c is equals to 0. Okay, now suppose I give you an expression. Let me give you an expression, x square minus 7x minus 2 is equals to 0. Now you can try the mid split over there. You will not find any numbers that will satisfy the product to be 2 and the sum to be minus 7. So in that case we'll have to use the quadratic formula. So directly we can use, and quadratic formula can be applied in the ones that can be found out through the mid split also. That is going to be minus of minus 7 plus or minus. Why is it that we are doing plus minus? Because typically we get two conjugate pairs of roots. Okay, I have already mentioned that the quadratic equation will always have two roots, alpha and beta. Let's see. So minus 7 ka square is a 49, and 4ac is a minus 4ac is a 8 plus 8 divided by 2. That's it. Coefficient of a is 1. So you get 7 plus or minus root over, this is 57 upon 2. So you can at this point say that alpha will be this thing beta will be 7 minus root over 57 by 2. And as you can see, both of them are conjugate pairs. Okay. No, I don't want to give a lot of elaboration in this one because this is more like a refresher session, so I'll keep it at that. Now let's go to the idea of nature of roots. Okay. First of all, we have understood the quadratic formula, and the quadratic formula is minus b plus or minus root over b square minus 4ac upon 2a. Now this term b square minus 4ac without the square root is called the discriminant. Okay, I will not write it, I'll just mention it. It is called discriminant. Now, based on what the discriminant is, if it is less than 0, so for a discriminant d, we can typically have two cases. It can be less than 0 or it could be greater than or equals to 0. If the discriminant is less than 0, roots are imaginary. What does this mean? Basically, we will now go into the territory of complex numbers, which is not something cat will ever throw at you. So this is something that you will never find. We will always be looking at d greater than equals to 0. Now here also I would like to say that the two ideas are d greater than 0 and d being equals to 0. If d is greater than 0, always please understand we are always talking about the roots for the quadratic. Okay, when d is greater than 0, roots are real and they are unequal. This is important, the word is unequal. When d is equal to 0, they are real and equal. Please understand, there is one more branch that I would like to tell you. That branch is when d is a perfect square. And when d is not a perfect square. Okay, when d is a perfect square, this is something for your, if a question is based on this, then you can remember it. Roots are rational, and if it is not a perfect square, roots are irrational. If you just remember the last example that I used, d or the discriminant was not a perfect square. In that case, the value that we received were irrational. Okay, anything that is inside the root is an irrational number. Okay, also that is a very loose example, but then that is what it is. Now let's go to the next idea for quadratic equations, which is properties of quadratic equations. Now what are a typical property of quadratic equations? So for a quadratic equation f of x, or you can also call it a quadratic function, f of x equals to ax squared plus bx plus c, that has roots as alpha and beta, properties, the first property is that of the sum of roots, which is alpha plus beta. Alpha plus beta will always be minus b by a. The other one is the product of roots. Alpha into beta, that is c by a. Also, one more important thing at this point is a formation of forming a quadratic equation. Forming a quadratic equation with the help of the roots, I might add alpha and beta. We can do it like x square minus alpha plus beta plus alpha into beta, that is equals to 0. Now please remember, this is the way. If you have the roots with you, alpha and beta given, you can form the quadratic equation through the roots with the use of this idea, x squared minus alpha plus beta plus alpha into beta that is equals to 0. Please understand there is a negative over there. You have to be careful of this thing. Let us take an example that will make the idea concrete in your mind. So say, and this is a cat level question. So say if alpha and beta, I'll not write the entire thing. I'll just give you, I'll dictate the question. Say if alpha and beta are the roots of the equation. Now I'm giving you the equation 3x squared plus 5x plus 1 equals to 0. Okay. Then we have to find the equation whose roots are, you have to find the equation with roots alpha squared and beta squared. Okay. You can pause this video and try this out. But let me tell you that obviously you don't have to find the roots and then, you know, square the roots and then form the equation. Let's do this a little more elegantly. How we can do that is, for this expression alpha and beta, alpha plus beta can be very easily calculated as minus 5 by 3, right? Alpha plus beta is minus b by a minus 5 by 3, and alpha into beta is going to be 1 by 3. Now please remember, anything that has to do with quadratic equations, we will always use the properties. We will hardly have to use quadratic formula or anything. Even for cubic equations also this thing holds true. Now please tell me, what is it that they are asking? They have asking to form an equation with the roots alpha square and beta square. We have just now understood that that thing we can do with the idea x squared minus alpha squared plus beta squared plus alpha squared beta squared. So this is the equation. Do I know the value of alpha square beta square? No. But do I know the value of alpha plus beta? Yeah. But do I know alpha square plus beta square? No. So let's, you know, just square them. So alpha plus beta the whole square. Alpha plus beta the whole square is alpha square plus beta square plus 2 alpha beta. I know this thing is minus 5 by 3. I'll write it directly. This is 25 by 9. Alpha plus beta, I have no idea, alpha square beta square, but 2 alpha beta I know is 2 by 3. So I'll just subtract 2 by 3 and I'll get alpha square plus beta square. If you take 9 as the LCM, you'll get 25 minus 6, that is 19 by 9, that is equals to alpha square plus beta square. Okay, just substitute that value. This is going to be x squared minus 19 by 9 x plus alpha and beta. So you can write this as 1 by 9 alpha beta ka whole square, this thing ka whole square. Okay, now at this point you can multiply 9 throughout and you can get something like a 9x squared plus this is going to be 9 minus 19x plus 1. So this is the equation that we have to form. This is going to be the answer to the equation that we were supposed to form with these roots alpha squared and beta squared. Okay, that is all from quadratic equations.